Okay, so in geometry today, we introduced a new section called 3.1, lines and angles, okay? And then we introduced the idea of lines and angles, talking about three new words, right? Parallel lines, skew lines, and parallel planes, okay? So parallel lines are two lines that do not intersect, but that happen to be in the same plane. So that's important, right? If they are in the same plane and they're parallel, like I have over here, M and R are parallel, um, the red triangles will indicate that the lines are indeed parallel. And the way that we write that is like this. M is parallel to R. This little tiny looks like the parallel symbol for 11, right? It looks like an 11. So there's parallel lines. Like skew lines are two lines that do not intersect, but they're in different planes. Okay, that is important, right? They have to be in different planes. This picture doesn't really do it a whole lot of justice, right? So I can try, if I had a plane like that with a line going through it, like, and then I had a plane like this. That's kind of sideways, so let's get rid of this line. Oh, yikes. So that's kind of sideways, right? Right? These are skew lines, right? Because they're in different planes and they don't intersect, okay? Even though it looks kind of like, but I did give an example in class with two real actual sticks, so it looked a little better. Okay, then I had parallel planes, right? Which is pretty straightforward. Two planes that do not intersect, such as like, the ceiling and the ground, right? The ceiling, think of that as a plane, and the ground, and those don't intersect, so those are parallel planes. Okay, then we talked about two important postulates, right? One was the parallel postulate, and then the other was a perpendicular postulate. And we took some time developing this, right? We said that the parallel postulate says that there can only be one line that is actually parallel to our line L that goes through point P. So my black line is line L. I have a single point. The red line is the only line that can be parallel to L and goes through P. Because if I had a different line, right? Let's say I had this line, this blue line, right? Well, that would intersect L. And if I had this line, that also intersects L. I mean, all three of these lines go through P, but only one of them, the red one, is actually parallel. So that's what the parallel postulate tells you. Similarly, the perpendicular postulate tells you that there can only be one line that is perpendicular to line L through point P. So again, I could have lots of lines that go through line L and go through P, but only one of them, the red one, will be perpendicular, which of course means intersect at right angles. Then we did a construction today. We did a construction of actually the perpendicular postulate. So make sure you can do that with a compass and straight edge. We did that. And then last thing we spoke about were transversals, okay? So if we have two lines in the plane, they don't necessarily need to be parallel, but if we just have two lines in the plane like I do M and L here, and we stretch another line over it, that line has a name. That line becomes a transversal line. And when you do that, you break the transversal. The transversal breaks these two lines into 8 angles. And I've labeled all of those angles right there. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 different angles. And the way that these angles are related to each other are classified by all these different angles down below. They could be alternate interior angles, corresponding consecutive, or alternate exterior. And what we did was we developed a few of those. So alternate interior, here's an example. Angle 3 and angle 6. Let me get rid of this, get rid of that, get rid of my 1, 8. So oh man, where'd my transversal go? Shoot. There we go. Okay, let's go 1 and let's go back to 8. Okay, so angles 3 and 6, right? So 3 and 6 are alternate interior angles. They're alternate sides of the transversal, and they're on the inside of M and L. So alternate interior. So are 5 and 4. Okay, we also did that. Alternate interior. So there's my 3. So these are the purple ones, the 3 and the 6, right? Okay, corresponding, right? An example of corresponding are 8 and 4. 8 and 4 are corresponding because they're in the same location, right? They're in the bottom right of the transversal and line L, bottom right of the transversal and line M. So that's an example of corresponding, right? 3 and 5 are consecutive interior lines, which means that they are next to each other on the inside of the two parallel lines on the inside of the transversal. So 3 and 5 are consecutive interior, and 1 and 8 are alternate exterior. So alternate means alternate side of the transversal, and exterior on the outside of M and L, right? 2 and 7 are also So angle 2 and angle 7 are also alternate exterior lines. So all those are the green ones, right? So we can go 2 and 7 if we wanted to for all that. Okay, that's the gist of section 3.1, and good luck.